Greetings, Houdini Python users. Now, the topic for this next two sessions is the Who.geometry class. Now, there's a lot to take in for this lesson, so I want to make sure that the basics are understood before moving on. Now, I'm going to be referring to classes which we haven't covered yet, such as the Who.point class, but you will always find information for these in the Who.docs. Now, a geometry object contains the points and primitives that define a 3D geometric shape. For example, each SOP in this Houdini SOP network generates a single geometric object, and the easiest way to access that is to assign them to a variable, and we do that by, we're going to create a new variable, and you drag and drop a node onto that, and you access its geometry information by declaring this method, geometry. All right, spelled wrong, geometry. Okay, now we confirm that. Okay, we've got a Who geometry object. Now, the geometry data is read-only reference to the data stored in this SOP, which means Houdini won't allow the geometry to be updated at this stage. Now, it is possible to manipulate the geometry information in a Python SOP, but we'll be covering that near the end of this course and actually at the end of this lesson. But the first method we're going to focus on is the points method, which returns a tuple of point or Who.point objects of all the points in the geometry. And we access that by accessing the points information. So points equals geo.points. Okay, we're going to end up with a very large cacophony of point information. Yes, we got the Who.points. But to make better sense of this, we can actually write a little for script to take a look at the values of these. So point in points are oops. I'm going to create a little variable called pos, which is going to store the point 3D information. So point.position, and then I've got a little print function here, which is going to print the value of each one of these points and its 3D coordinates. So I'm going to put a little comma there. And we have the rest of the statement here. I'm going to terminate this here. All right, so we have the point information for each one of the point numbers. So this has the x, y, and z 3D coordinates of each point. Now, if we wanted to access just a tuple of points corresponding to a pattern of points, then we use the glob points function. And the glob points behaves just like the points does. So glob equals geo.glob points. Now I'm going to give it a subset of 30 through 39, and we're going to do it on 2s. All right. For those used to Houdini nomenclature, you should recognize this statement. Now we're going to use the exact same for loop in order to rifle through the values of these glob points. So glob, all right, we've got our position information, we have our print statement, and then we have the position information of the points 30 through 38 on 2s. Now, before launching into the primitives, there needs to be a little bit of coverage on the Who.vertex class. A vertex object is contained in exactly one prim and references exactly one point. Now, you can only access the vertices through the geometry's primitives. With that said, let's roll on to the prims class. Now, the prims returns a tuple of Who.prims, or the primitives of all the geometries. Now, the primitives returned will be a subclass of Who.prim, whether that be polygons, volumes, meshes, or what have you. So we're going to create a new variable called prims equals, let's see, geo.prims. All right, we have, and we're going to get a whole mess of primitive objects, but they all are of type, well, let's say Who.polygon, which are a subset of Who.prims. But in order to go to that, we're going to have to create another for function in order to rifle through all these values. So we're going to say for prim in prims, all right. We're going to create a vertex variable for every one of these primitives. Okay, so verts equals the prim vertices, so verts now stores a tuple of vertices. Now I'm going to create a buffer so that we can store our information string as we collect it. Then we're going to go through every one of the vertices, and then we're going to grab its point number. But for that, I'm going to need this little for statement that's going to rifle through all of the points within each primitive. And I've got this for loop right here. Let's say for I to be in the range of prim.num vertices. Prim.num vertices returns the number of vertices in that primitive. Then I'm going to update the buffer string to collect that information. Now I'm going to terminate the buffer string since we're done with that primitive, and now we're going to print that primitive's values out. All right. So what this is basically says, I want to print each primitive number with the vertices of each primitive, which are all the vertices of each primitive. Okay, and there we have all of the polygons or primitives listed within that red object, and these are the point numbers associated with each one of those primitives. Now we can use glob prims to return a tuple of primitives corresponding to a pattern of primitive numbers, and this behaves just like points. I'm going to say glob equals glob prims, geo dot glob prims. Oh, I want to give it a value of, I don't know, 60 to 70 on 3s. Oh, what the hey. Okay, we have we forgot to terminate the string. No problem. All right, now we're going to go through and use the exact same function that we used before in order to print out the values of that these glob primitives. So we're going to create all right, instead of prims, I want to use glob. Now I'm going to grab its vertice information. I got the buffer information. Now we're going to go through all of the indices, or go through all of the verts within the primitive. We're going to append those to the buffer string. We're going to terminate our buffer string. Okay, as we terminated our buffer string, we want to do that at the primitive level. Buff plus equals. Okay, now we want to print our values out. All right, and we have the primitives 60 through 69, and these are the point numbers for each of those primitives. Now we can use methods such as glob vertices and glob edges, which returns tuples of those who.vertices and who.edges corresponding to the edge patterns. Now, as a wrap-up, in this session, we discovered the basic point, vertex, and primitive querying techniques from the who.geometry class. In the next session, we're going to continue with the exploration of the who.geometry class with querying geometric attributes and a quick introduction on how to create geometry from within the who.geometry class. I'll see you on the next lesson.